I hope the topics that were discussed yesterday, you are done with those topics. Today we will be starting the new topic. Okay. So, all right. So, children, this is about the conduction of electricity by the aqueous solution of acids. Yesterday we discussed that acids conduct electricity in the aqueous form. They conduct electricity in the aqueous form. Now we know aqueous form means the presence of water, the acid having water into it. All right. So today we are going to discuss how does this happen. So let us see this. The setup is there as shown in the slide. You can see yesterday we discussed this. Here the acid is there. It made the bulb glow, which indicates that the acids are good conductor. So what actually makes the acid good conductor of electricity? It is this reaction that you can see here. This hydrochloric acid in aqueous form splits into ions H plus and Cl minus. This process is called ionization. The acid got ionized in this process. If we take the example of another acid, nitric acid, it also splits into H plus and NO3 ions. So ionization took place here also. If we take the example of one more acid here, sulfuric acid, the same thing happens, H plus ions and sulfate ions. And same is with the acetic acid, the weak acid. It splits into acetate ions and hydrogen ions. So everywhere you can see when the acids are taken in the aqueous form, they produce H plus ions. And these ions are responsible for the conduction of electricity. Whether they are strong acids like HCl, NO3, H2SO4, or a weak acid like acetic acid, they all will conduct electricity. So if you have a question that what makes the aqueous solution of acid conduct electricity, the answer is the production of ions. Because the ions get produced here, they conduct electricity. All right. So here you can see just a second. I'm sharing the presentation again. Just a minute. Okay, so the screen is there in front of you. Let me go to the slide which we were there on. See. Yes, so this is the slide we were discussing. The diagram is clear. It says that the acid is there in water and it has produced H plus and Cl minus ions. But if you take something else like glucose, C6H12O6, this is a substance which contains hydrogen into it. If you put it in water, it will not produce ions. You can see the diagram. It has not produced ions. The molecules are intact. There is no splitting, no ionization took place. And that is why glucose will not conduct electricity, but acids will conduct electricity. So here you can have a 1 marker, 2 marker, or 3 marker question asking why is it that the acids conduct electricity, but glucose does not. So the answer we know now, that because the ions get produced here, the acids conduct electricity, right? So here the other diagram will make it very clear what actually happens to the glucose. This is the sucrose molecule taken here. It is another kind of sugar. So when you put it in water, the only thing happens is the lump of sugar breaks down into small pieces, but ions are not produced. So it will not conduct electricity. These, you can see the pieces breaking down into two, but no ionization. All right. So now the things are very clear. This is the question based on the concept. Why do HCl, HNO3 show acidic character in aqueous solution, but compounds like alcohol and glucose do not show acidic behavior? The answer we have seen on the last slide. Because the ions get produced, the acids show acidic behavior. It will split into H plus and Cl minus. But C6H12O6 will not produce any ions. So that is why they do not show any acidic character. Basically, for an acid to show the acidic character, these ions are important. H plus ions are important. All right. These H plus ions react with water, or they combine with water to make H3O plus. These are called hydronium ions. So ultimately the hydronium ions will have all acidic property. If hydronium ions do not get produced, it does not show any acidic property. So basically, if hydronium ions are required, we need two things. They are hydrogen ions and water. If any one thing is missing, it will not have any acidic property. A similar kind of question based on the same concept. Compounds like alcohol and glucose do not, they contain hydrogen, but they are not categorized as acids. So the answer is the same. They are asking you to explain in the form of an activity. The same activity you can take a beaker and you can take one by one acid and alcohol into it. You can show the circuit the way it was shown in the diagram, and then you can say the alcohol or glucose are not making the bulb glow because they don't have acidic property into it, but acids have such property. So in this way, you can explain the answer. Okay. Now, you can see a diagram in front of you. There are certain beakers and certain flasks. Let us see one by one what they are. The first thing is NaCl. This is the common salt, sodium chloride. It is taken in this round bottom flask, this one, right? And you are adding sulfuric acid into it, H2SO4. You are adding into it. So the reaction takes place between the two. And because of this reaction, HCl gas is produced, this one, HCl gas, which is called hydrogen chloride gas. This gas is produced and it will pass through this pipe. It will pass through this pipe and it is made to go into this beaker containing concentrated sulfuric acid, this one. This is concentrated sulfuric acid. You can see the bubbles of gas. This is HCl gas. Now the purpose of passing hydrogen chloride gas into the acid is to remove the moisture from the gas. Means what is to be done is Okay, what is to be done is this HCl gas has to be collected in dry form. We do not want any moisture into this gas. So the method is, let the gas come in contact with sulfuric acid. Sulfuric acid will act as a dehydrating agent. Dehydrating agent. Dehydration means removing water. So once the water gets removed from this, hydrogen chloride gas in absolute dry form will come into this beaker. This beaker, you can see this one, right? So in this reaction overall, the hydrogen chloride gas is produced, which is collected in absolute dry form. I want you to take a look at the diagram nicely and read the labels nicely so that you understand what exactly happened. I'm repeating again. NaCl, sodium chloride, reacts with concentrated sulfuric acid to produce HCl, hydrogen chloride gas. This gas contains some moisture into it. We want to remove the moisture. So let it come in contact with another beaker having sulfuric acid. This sulfuric acid will remove water. Now HCl gas in dry form is collected. Okay. Now when we see the formula HCl, it is very clear that it will be having acidic property, right? So far we know, we have been discussing about HCl, hydrogen chloride, hydrochloric acid. So we know it should have acidic property. This is the reaction of the previous, the diagram where we discussed the reaction between these two and HCl gas is produced. So I was telling you HCl should be having acidic property. It means it should change the color of litmus from blue to red, right? Because it is acidic in nature. Now what we are going to do is, let us check it. Let us confirm this. So blue litmus paper is brought in contact with the dry HCl gas. A blue litmus paper is brought in the contact. But surprisingly, it does not change the color. No change in color is seen. But when this litmus paper is made wet, then it changes to red color. See the diagram. You can see the litmus paper. It is moist litmus paper. It is blue in color. When it comes in contact with this HCl gas, here in this test tube, the HCl gas is there. This part of the litmus paper becomes red. So it changed from blue to red. It was not changing when the litmus paper was dry. See, be careful. The gas is also in dry form and the litmus paper is also dry. At that time, you did not see any change into it. But when you made the litmus paper wet, you saw the change in color, blue to red, showing that now it is behaving like an acid. It means water played a major role here. The presence of water produced H plus ions. And remember, a few minutes back, I told you that it is these hydrogen ions which combine with water molecules to produce hydronium ions, which are ultimately responsible for acidic behavior. So till we get, if we do not get this H3O plus ions, it will not behave like an acid. So this shows the importance of water, the significance of water for some substance to behave like an acid. All right. I hope that things are clear till here. Meanwhile, if you have any doubt, you can just raise your hand or you can write it in chat box. Okay. So this is the one which I explained you just now. No change on dry litmus paper, but the wet litmus paper changed the color. And the reason is this ionization and hydrogen ions, right? So always remember, these ions are very much important if the substance has to behave like an acid. Now, the question on the same concept, why does dry HCl gas not change the color of dry litmus paper? The answer will be the same. No production of H plus ions, so no acidic behavior. No acidic behavior. Okay. Okay. Similar kind of question, why do acids not show acidic behavior in the absence of water? The answer is the same. All right. Now, so far we have discussed that all acids produce H plus ions. You can see whether it is nitric acid, perchloric acid, sulfuric acid, hydrochloric acid, whichever acid you take, it will always produce H plus ions. So depending on that, we concluded that all acids have hydrogen in them. But what about bases? A basic substance will always produce OH minus ions. Like for example, NaOH. If you put it in water, it will produce Na plus and OH minus ions. If you have KOH, potassium hydroxide, so children, the question here is that you are adding excess of base into it. The solution already you have is of sodium hydroxide. So when you have the solution of sodium hydroxide, it will have hydroxide ions present into it. And then you are adding excess of base into it. So what will happen to the OH minus ions? They are going to increase because already it had OH minus ions. Now you have added more base into it. So the answer here is more amount of hydroxide ions will be produced into it. All right. Now, all bases do not dissolve in water. We have several bases like sodium hydroxide, potassium hydroxide, calcium hydroxide, magnesium hydroxide. They all do not dissolve in water. The ones which dissolve in water are called alkali. So here you have a list of bases like calcium oxide, magnesium oxide, copper oxide, sodium hydroxide, potassium hydroxide, calcium hydroxide, ammonium hydroxide. Out of all this one is a base because it will not dissolve in water. All others are alkali because they dissolve in water. So basically the difference between base and alkali is this only, that alkali are those bases which dissolve in water. Okay? Rest all properties are the same. Okay, so here like you can have a question asking you the difference between base and alkali. So this is one point difference between them. Bases are the substances which neutralize the acid, but they do not dissolve in water. Copper oxide, iron oxide, zinc carbonate, they all are bases. But alkali is a base which dissolves in water and it produces hydroxide ions. NaOH and calcium hydroxide are the two examples given here. Okay. Under what soil conditions do you think a farmer would treat the soil of his field with quicklime, which is calcium oxide, slaked lime, which is calcium hydroxide, or chalk with it, which is calcium carbonate. All the three substances are basic in nature. They are mild bases. So now you must have got an idea in which condition these substances are added to the soil. If a farmer finds that the soil of his field is acidic in nature, then any of these substances are added to the soil so that the acidity can be neutralized and the soil can be prepared for agriculture, right? So if the soil is acidic, then these substances are added because they are mild base. You can have a multiple choice question based on this concept. The question can be like which of the following substance is preferred to add in the soil when the soil is acidic. So they might give you NaOH, KOH, along with these options, quick lime, slake lime, or chalk. At that time, please do not select these options because they are strong bases. They are strong bases and they are very corrosive in nature. So they will degrade the quality of the soil. So though they are bases, but they are very strong. So you should not be selecting these answers. Okay. Now, the next concept is mixing acid and water. We have been discussing that acids are in aqueous form. The presence of water is very important for something to behave like an acid. But the question is, how do we mix them? Children, it's not that easy that you take water and acid and you mix them. No, it's not like that. There is a process of mixing them. The process is you take a container, a beaker, you fill it with water into it. This is the water filled in the beaker. And then you add acid into it. It means you should always add acid to water and not vice versa. You should not be doing the reverse of it. What is the reason behind it? Let us discuss. Mixing of acid and water is highly exothermic. Let me write it on screen. When you mix acid and water, lot of heat is produced. Okay, lot of heat is produced. Now suppose in the container, you took water. As I explained you just now, you have taken water and you have added acid into it. The acid is coming in contact with the water here. Lot of heat is produced. Now this water will absorb the heat. The water which is present here, it will absorb the heat. So the beaker becomes warm in this situation. Please note my words. I am saying the beaker will become warm because most of the heat is absorbed by water. Right? Heat absorbed by water, right? This is situation one. Let us see another situation. This is situation two. This time you have taken the beaker and you took acid into it and you are adding water. Okay. When you do so, the water when comes in contact with acid, heat is produced, right? But acid will not absorb the heat here. Acid will not absorb heat. So the heat which is produced reaches the beaker as it is immediately. The beaker becomes hot and it breaks. The beaker becomes hot and it breaks. So it will be risky because the acids are corrosive in nature. So there are chances that somebody can get hurt. So this second method is not recommended at all. You should never add water to acid. You should always add acid to water. You should always add acid to water, right? So this is the correct way. The topic is very simple, but there are questions that they ask on this concept. You can see here, this diagram shows that the person is putting acid into water, and you can see these fumes. This is the steam. The steam got produced because the water became so hot. So imagine this is the small amount of acid being added. If large amount of acid is added, it can hurt somebody. So this is the warning sign that is there on the bottles. Add acid to water. Okay. So the reason I have already explained. Now you can see the question: while diluting an acid, why it is recommended that the acid should be added to water and not the other way around. So you can see the answer. I have just now discussed it. You can write the answer in your own words also. The only thing when you write the answer is you must never miss any important point, any keyword. Okay. Now, the other question, how is the concentration of hydronium ions affected when the solution of an acid is diluted? Let us understand this question and then we try answering it. It says that you are having an acid into a beaker, this one. Because you have an acid, it is having H3O plus ions definitely, right? Now, when you dilute this acid, it means when you add water into it, its acidity decreases. Its acidity decreases. Because the acidity decreases, these hydronium ions become less. So the answer here is the concentration will reduce. It decreases. Right? So when you are answering these kind of questions, you can do your rough work the way I did right now. There are several acids. They are not equally strong. They can be strong or they can be weak. Now, what decides whether an acid is strong or weak? See, children, this diagram will make you understand this. Strong acids are the ones which completely dissociate in water. A few minutes back, remember I explained you about ionization. Ionization is a process in which the acid splits in the ions H plus and Cl minus in this case because we have hydrochloric acid. Now, suppose we took 100 molecules of HCl and we added to water. If all 100 of them produce H plus ions, if all 100 split into ions, we call it complete ionization. And that makes HCl a strong acid. Okay, you can see in the diagram is HCl one molecule, second, third, and fourth. All four molecules are splitting here. You can see all four of them got ionized. So this is 100% dissociation. So it is a strong acid. But if there is partial dissociation, means you start, in this case, you can see 1, 2, 3, and 4. You have 4 molecules of ethanoic acid. This one did not split. This one did not split. This one did not split. Only one ion got split. Out of 4, 3 did not split. Only one ion, one molecule got split. So this is partial ionization. That makes it a weak acid. So strong and weak acids can be decided on the basis of the percentage dissociation, right? If it splits, this is another diagram explaining you the same thing. Here also 4 molecules of HCl are there, 1, 2, 3, and 4. After the reaction, all 4 of them are splitting. You do not see any green line in between, which was there here. This green line is a bond. After you add it in water, all the green bonds are broken, complete ionization. So this is a strong acid. But here, out of the 3 molecules of ethanoic acid, only one got split. You can see here. Rest 2 are still having the green lines here. So it is a weak acid, right? So the strength of the acid, again, I'll tell you, depends on the ionization percentage. If it is 100% ionization, strong acid, else it is a weak acid. Examples here are HCl, H2SO4, HNO3. These 3 acids are strong acids. And here you can have example of acetic acid, vinegar, right? So I would like to ask you if you have any doubts here. You can ask your doubts if you have any. Any doubt to anyone? You can write in the chat box so that I understand whether you have any doubt or not. No doubt. I hope you understood. At least tell me something. Give me some indication that you are getting the topic. Yes, children? So should I continue with the topic? Yes. Should I go ahead with the topic, children? Okay, so let me go further. Okay. Let me go further with the topic. So strong and weak acid you have understood. Now, suppose you have 2 test tubes. This is test tube number 1 and this is test tube number 2, right? It contains substance A and this one contains substance B. And somebody tells and comes that and tells you that both the substance A and B are acidic in nature, right? But one of them is a strong acid and the other one is a weak acid. There are no labels on the test tube. You don't know. They look like the same. Both are colorless liquids. So how to get to know which one is a strong acid, which is a weak acid? Remember, it depends on the number of H plus ions. If the number of H plus ions are more, it is a strong acid. If H plus ions are less, it is a weak acid. But how do we count them? It is not possible to count, right? So we can take the help of a pH paper. pH paper is just like litmus paper. It is just like litmus paper, but to make litmus paper, you need litmus solution. Here you need a universal indicator. Let me write it here. Universal indicator. Now, universal indicator is the mixture of all indicator. Okay, let me erase this part. Just a second. Universal indicator is the mixture of all indicators. Mixture of all indicators. Now, what is the need to mix all the indicators? See, some indicators will give you a result for only weak acids, but they don't work for strong acid or strong base, right? Some might work only for a strong base. They won't give you the result for strong acid or other weak base. So what do? They simply mix all the indicators and they make one universal indicator. Now the paper strips are soaked in the universal indicator and you get the pH paper, right? So this pH paper is originally yellow in color. Now, when you put a drop of, suppose this is the pH paper with you, which is yellow in color, okay? And you are putting a drop of unknown substance on it, unknown substance, and it becomes red in color. Then you are very sure that this substance is acidic in nature. If, if it becomes blue, then that substance is basic in nature. And if it becomes green, then this substance is neutral, right? Let me show you the diagram so that you can understand. See, here pH is potence of hydrogen, power of hydrogen. The more the hydrogen, the stronger the acid is. If hydrogen ions are more, it is a strong acid. If hydrogen ions are less, this. If hydrogen ions are less, so let us now see this over here. See children, this is about the universal indicator. These are the pH strips. Now, this diagram will make it clear. You can see here, this is an unknown substance taken here. And the pH paper, which is originally yellow in color, changes to blue. So this unknown substance is basic in nature. This is the standard pH chart. You can see it shows red, light red, then pink kind of, then orange, then green, and then the shades of blue are there. So it starts with acidic substance, then these are the neutral substances having pH 6 and 7, and then we have 10, 11, 12, 13. So basically, pH value is from 1 to 14. pH value is from 1 to 14. 1 to 14. The substances which are acidic in nature will have pH 1 to 7. The basic substance will have pH 7 to 14. And the neutral substance will have pH exactly 7. Right? So you can read here, it shows pH 1, 2, 3, 4, 5, 6. These are all acidic in nature. This is 7. This is neutral. Then 8, 9, 10, 11, 12, 13. These are all bases. So this color change will let you know. You can see this another diagram. So acidic substances show red and shades of red. Basic substances show blue and shades of blue, and neutral substances show green color. Right? So this is now this is the list of some common substances with their pH values. You can see here, the battery acid is the strongest. It is having pH 0.5. Gastric juice, it has this hydrochloric acid. You can see how strong this acid is, 1.5 to 2 pH. Then lemon, cold drinks. Cold drinks are acidic in nature. You must have heard elders saying that you should not be having more cold drinks because they are not good for the health, because they are acidic in nature. Vinegar is 2.9, right? Then here you can see pure water is 7 pH. It's neutral. Then saliva has to be slightly acidic and slightly basic because the digestion can take place nicely. Blood is slightly alkaline, basic in nature. And household lye, it is the caustic soda which is there in dishwash. So it is, see how strong it is, right? So this gives you an idea that we use several substances in our daily life which are acidic or basic in nature. Okay. Now, the other concept, the importance of pH in our daily life. Children, in our body, several reactions take place, like digestion is the main reaction, is the main process. During digestion, several chemical reactions take place. So they have the optimum pH of this. 7 to 7.8 is the optimum pH. If it is not maintained, then people suffer from indigestion. People suffer from indigestion, right? Now, another thing is these small organisms, lower aquatic organisms, they get affected very badly. You must have heard about acid rain. Acid rain. Acid rain is the one which contains acids into it. Now, you very well know, you have learned it in the previous classes that some gases like sulfur dioxide, nitrogen dioxide, carbon dioxide, they are responsible for acid rain. So when the rain is acidic, it will harm the lower organisms which are there in the soil, like larvae of small organisms, some fish, other aquatic organisms, they get affected badly. So like here you can see a chart is shown which says the pH from 4 to 6 is very bad for them. If the pH is 4.2, all fish will die. If it is 5.5, these small organisms like the eggs of the frog, tadpole, crayfish, mayfly, these are the kind of fish, they will all die. Then at pH value 6, rainbow trout, it is also a kind of fish, it will die. So it hampers the entire food chain, right? So this is the second effect of pH on organisms. The question is why distilled water does not conduct electricity. It does not have any ions into it. It does not have any salt into it, right? Tap water will have. Now this diagram is very clear. It is showing a species of plant growing in different pH of water. This is the tap water. This is acidic with pH 5.6. This is more acidic with pH 4. This is highly acidic with pH 3. You can see out of all, only this one seems to be healthy. Others are not growing well. They have a deformed kind of growth. So this is not the proper growth. It is because of different pH value. So we should take care of the soil in which we are growing the plant, also the water with which we are watering the plants. It should not be acidic. It has to be neutral. So this was the second effect. Uh, Here the question is you are having two solutions A and B. The pH of A is 6 and B is 8. Which has more hydrogen ion concentration? The one which is acidic in nature will have more H plus ions, right? And A is acidic here and B is basic because now we know the pH values. So A is acidic and B is basic in nature. Then what effect does the concentration of H plus ions have on the nature of solution? So it's very clear now, more H plus ions will make the solution acidic. All right. Here another diagram showing you about the tooth decay. Tooth decay occurs when the pH of the mouth becomes less than 5. See, we keep eating sugary fruits, sugary food, chocolates and all. Now, when we eat that, it gets decomposed in the mouth and acid production takes place. Now, this acid damages the enamel of the teeth. Enamel contains calcium phosphate. Calcium phosphate. This is a protective layer on the teeth, but these acids will corrode the protective layer. So the teeth develop cavities into it, right? So this happens because, as I told you, the pH becomes less than 5. Less than 5 क्यों हुआ? Because acid production takes place. So first advice is have less amount of cold drinks and sugar and chocolate. Second, you should brush your teeth with a toothpaste which is having mild base into it, The reason here is the base will neutralize the acid which is there on the teeth, right? So here you can have several questions based on this topic. They can ask you what is the substance present in the enamel? Why does it get corroded? How the pH of the mouth becomes less than 5.5? What you should be doing to get rid of this. So all this we have discussed on this slide. And the last topic of the day is self-defense. There are certain insects like bee and wasp. They have the sting. It contains acid into it. A bee sting has methanoic acid. HCOOH is the acid. That's why it gives itching and irritation, right? So the remedy is you should be applying mild base like baking soda on it. Some plants like nettle plant is having acid into its sting. Again, the acid is methanoic acid here. So if you happen to touch this plant, it gives you irritation. So the remedy is this plant. This is called dock plant. It is having mild base into it. So you should apply a paste of this plant on the affected area. So this was the topic of importance of pH in our daily life. So we have completed this topic.